everyone. So welcome to our special session, right? ECS Thailand Section and the E-Asia Respect special webinar. Okay. So today is we already invite Professor Nurak Grisdanurak to give a talk on lithium-ion battery recycling process, the crunching unit in the first plant in Thailand. Okay, so Professor Nurak Grisdanurak is from Chemical Engineering, Thammasat University. Okay, so Professor Nurak, are you ready for the talk?
Yes. Thank you.
Okay, so I will give the stage to you. So
Yes.
everyone, please enjoy Professor Nurak's talk. Thank you very much. Please go ahead.
Okay. Well, good afternoon. Good afternoon, professors. Good afternoon, fellow young scientists, and anyone who are interested to this talk. Show up in this streaming. All right. Well, thank you for having me here, and kind of exciting to give a talk, and this is my first time to give a talk in this kind of streaming. Before I begin, I would like to express my uh, sincerely gratitude to Professor Rojana to inviting me to this kind of event. And of course, today my name as Professor Rojana has been introduced to you guys, and now I am excited to share about my research. This is about lithium-ion battery recycling process, and as you know, that there are two parts of the recycling process. One is a crushing unit, and the other one is hydrometallurgy unit, right? So now I would like to share about the first unit, and we claim that this unit is as the first plant in Thailand. What I would like to share to you is about the laboratory work until we process that to industrial practice. Uh, let talking about something that I have give a talk to the seminar in Indonesia. Of course, the market share of electric vehicle has been increased, right? Not only in Thailand but also across the region. If we look at the statistical data for Indonesia, we found that uh, this EV has been projected to being about 600,000 electric vehicle by within another 5 years from now, and that would be projected to reduce carbon dioxide more than about 160,000 tons a year. The reason that I use this data because we don't have this kind of reduction carbon dioxide emission if we implement amount of electric vehicle in Thailand that much. So you can approximate by yourself that how many vehicle do we have and how much of the CO2 emission that we can reduce annually. Well, when we talk about electric vehicle, what I mean is not only for the four-wheel vehicle, also we are talking about two-wheel vehicle that what we can find for motorbike, scooter, and some other bicycle, right? Well, let's see what happened in Thailand. We can get the information about what happened in Thailand, which is a bit beyond the information of Indonesia. When we add the data of electric vehicle together with the plug-in hybrid electric vehicle, we can find that about more than 50% of the portion that we starting to try to catch up with the other type of vehicle. What I mean is internal combustion engine. Well, as you can see that the increasing number has been grow up very rapidly. So what we can do now, we have to think about in the final 7 to 10 years from now, we would get some kind of problem in terms of electric vehicle battery, especially for the end of life batteries. On the right hand side, this is a general way that they take care the EV battery for the big vehicles like a car or trucks, right? So what they are doing, just put the EOL end of life battery into this kind of furnace, and this furnace, the picture that's showing here is just the normal operation, just like incinerator attached into the any power plant, and then they operate at about 800 degrees Celsius for a very short time. And of course, when you look at this capacity of the furnace, it can be handle the process not very big, about 4 tons a day. So if you imagine that if you imagine about how many cars that we have to how many times of the incinerator that we have to take care, right? Because one car might be about a ton of the EV battery that put in. So this is quite about only 4 cars that they operate for one day. And the picture right here is the kind of battery that they put that in this kind of furnace. Well, what we are talking about, not I need to be exclude this kind of battery because it's quite heavy, right? The power and the way to do the discharge is quite heavy, so we cannot take care for this kind of vehicle battery. We have to look for some other kinds of battery like a Tesla battery, the golf vehicle, the hotel vehicle that they use electric card to take care of the customer, as well as the drone battery for drone, and also the power bank, as well as those small battery that they buy together like that. As you know that the battery that we use in recent year contain such very precious metals like lithium, cobalt, nickel, and manganese. Some of them may produce from iron and phosphorus, phosphate. Okay, and again, we don't have that kind of natural resources in Thailand, unfortunately. So what we have to do, we have to take care of that precious metal under the recycle process to make sure that all the precious metal need to be retained in within the country, right? Unfortunately, we still don't have this kind of national policy in our country to keep such a precious metal inside and then do the reprocess for the second life or other new EV fabrication. Unlike other country that they have the reserved precious metal like Indonesia, you can see that they last week I went to Indonesia and we talked about the way that they do any recycling process in Indonesia. They said that they don't have this kind of process, only in terms of underdeveloping way to make a new a factory or only in a research lab. Okay, I think the reason that they do not interested on that because they have a lot of nickel reserved inside the country. That is my expectation. So I would like to get back to what I have done in our research. We started in about 2019. In the beginning of 2019, we start to have EV1, which we work on the lithium battery recycling study on the laboratory scale. The project was granted by EGAT. EGAT is the enterprise that uh, they have some kind of funding and try to do something about the energy issue. So in that case, we got about 1.5 year projects to work on this laboratory scale. So I will tell you later about the detail on that. And after we finish the EV1, we got the grant to continue the work on the first part of recycling battery, and this is to focus the focus of this project is to produce black mass from the lithium-ion battery. Also, the project was granted for 1.5 year. We call that EV2. We already finished that, and now we are on the state of the second part of lithium battery recycling process. Of course, this is hydrometallurgy unit set. If we put them together, we will we will confirm that this might be a very successful story of the lithium-ion battery recycling process. So now, fortunately, this proposal has been approved, and we expected to start the project next year around February, I think. All right. Now let's see what happened in our EV1. In EV1, we on the left-hand side, you look on the left-hand side, there are two parts. One is a crushing part, and the other one is we draw something that can be like a semi-automatically operation system. This is as well. So we connect. We do some kind of research, literature review, and we think that okay, we should have a shader. We should have some kind of keep, correct those volatile organic electrolyte. So we expect to have like a vacuum pump and also some kind of condensation, so we can keep the vapor that generate during the crushing, and if something happen, I mean during the process we try to avoid the fire explosion. We use the nitrogen supply to keep the system without oxygen. And also we expect to get dust or particulate emission during the crushing and shredding. So we connect with the cyclone and dust collector, blah, blah, blah. So this is what we expect in the first part in the proposal. And now we construct something that similar to this, but you cannot see that we have the nitrogen cylinder here to support to avoid the system under oxygen, and also we have the cyclone, and those we try to connect vacuum pump and condensation system. However, we couldn't do that because the system is not totally closed. So what we use, we have to arrange the way to do by using adsorption to avoid some kind of smell and odor during the process causing by electrolyte. So this is, we have the screener, we have the crusher, and this is our product after we have a small crusher like that. Of course, these three samples, after we get from the screening point, we use that for the second part. This second part is the acid reaching, and also we after doing the acid reaching, we need to do the filtrate the solution, and then what we have to do next is to precipitate those kind of precious metal out by adjusting pH. And the way to get lithium carbonate, we use carbon dioxide cylinder to bubbling in this to demonstration beakers. And also this is the unit that we construct under several things like a heating system, the pH controller, and the temperature controller, and what else? I think agitator, right? This is very simple. So temperature control, pH control, and CO2 bubbling that put together in the system. Next one. So now from that process, EV1, we get all procedure, all step by step to get the precious metal from starting point from the EV battery, spent EV battery or end of life. Now we go to EV2. EV2, we try to develop for higher capacity. As you can see that we put that in terms of a pilot scale. So this is just to produce black mass and do some kind of separation from electric vehicle. Of course, we will not include very big car like truck, electric battery truck, or any general car, four-wheel car. We work on those kind only to from the small car inside and using inside the industrial, and also the motorbike and just bicycle, electric bicycle instead. So this is the unit look like. The unit is quite similar to what we have in EV1, but just want to make sure that the system go continuously. So we have to put them into like a 3 sets. So we have 3 sets of cyclone, we have 3 sets of filter, backhouse filter in terms of separation, clean up the air, and 3 sets of screener. And we have only 2 sets of crusher and shredder. I mean, 1 shredder, one crusher. On the right hand side, this is a kind of a product that we have. You can have very fine powder of black mass. We can have some kind that contaminate those copper sheet inside the EV battery, and also we get some copper sheet and also aluminum sheet that we can separate from it. So if you look at this, the product can be sold in different price, right? And some of them, as you can see from here, is a kind of small sheet, small plastic sheet that we can also use as a raw material for to burn in terms of separation, because some literature reviews said that if we can do that by increase temperature a little bit, we can use the phosphoration to separate precious metal from black mass easily, from graphite easily. Okay. In that project, not only to construct the system of crushing and trading and separation of black mass, we also do some kind of the procedure or safety guideline to on the preparation of battery. Of course, the battery, if there is no short circuit, it's okay. But if something that the circuit has been broke down, you can get fire explosion. And if you have if the voltage inside the battery is quite big, the small bomb can be occur in your area. So I think this is the kind of that we learn, that we can set some guideline of the safety in terms of preparation part of the battery. We also working on the health and environmental list for any worker in this process. So we work in about like a 6-day operation, separately into 3 sets. So we can take care, check for the health and environmental area. And we also providing the education to community. Of course, we because what you can see is kind of like a big factory, a small factory, like a small factory. So people or the worker in that construction area may concern a little bit on in terms of hazardous material or not, the emission. So we have to give education a little bit to the person who may get involved or come across or maybe go by to our process area. We also doing some kind of life cycle assessment. So this is to understand about the environmental impacts, comparing to the incineration part. As I showed you before, right? There are 2 kinds. One is using incineration to produce the black mass, and the other one that we are doing now, we use the crushing process to produce the black mass. So the environmental impact here that we do the study, we have to compare between these 2 scenarios. Unfortunately, we also did some work on electrostatic plasma. However, the result not very clear and good enough to present. So I just want to skip the fifth part of this. All right. This is what happened in the incinerator. I visit this kind of work again. So the furnace is about the attached parallelly to the existing incinerator unit. So as you can see, the emission of after the burning process in the furnace, the emission go to connect with the air pollution system. So if we have to construct the incinerator itself, it means that you need a treatment system at the downstream process. So the cost will be very much increased in very big investment. However, to reduce the cost of that, that's why they attach this incinerator to the general power plant. this is this battery has been December before, and this is a car battery. However, if you look at the one below here, this is just what we get from EGAT. This is a battery from the truck. So the way they, they, they the assembly is to put this battery together on different cells, and they bind it with some kind of soldering, especially for the lead soldering. So it's quite hard to take them apart. And also these are battery put in very strong case, very strong case, because they afraid that if some accident happen or some big collision, so the battery will not cause the domino effect to new explosion after the collision. So for the big car, for the big EV car, we cannot take care of this. So the one that we are working is just small and medium size of the battery that we are talking about. So now take a look on our EV2. This project has been working together from 4 universities, of course, Thammasat, Bangkok, Mahasarakham, and Silpakorn. We work together, and the capacity that we have is about 400 kilograms per day. Of course, we can operate higher than that, but some problem happen, especially on the way we correct the sample, because the way to correct the sample is not a closed system. We don't have people, I mean, many workers, many graduate students to take care. So we can handle only 400 kilograms per day. Total for the whole project, we run for about 2.6 ton of the income battery, I mean spent battery. Look at the picture below here. This is our battery getting from the motorbike. As you can see here, there is a handle here. So this can be replaced. Just hold the battery out from the motorbike, and then put the whole cell into the system. So the case is quite heavy, right? And the case is about 2 kilograms, and the battery inside is about 25 kilograms of the battery inside. We get the battery from the EV shops, motorbike shop. This is also, we got that from the motorbike shop. As you can see here, there are on different kinds. This might be LFP, and this might be LMO or LCO. We also working with those laptop battery and also the drone battery. However, before doing that, we need to do that. Take the case out and do some kind of disassembly. And the picture here is just the cell inside this battery, right after we do the assembly. Okay, this is disassemble one. So as you can see here, after we take the first part, the cover out, you can see some kind of lead soldering. So we don't want these to be contaminated into our crushing system. Otherwise, the way to do the separation, refine precious metal will be difficult. So we need to take all the soldering out, binding part out. It's quite difficult to do by the machine, right? Because different configuration, different way of soldering. As you can see here, the way they put them together different from this one. So machine or any automatic machine in the near future, that why don't we use the machine to do other rather using all the worker or manually, because different configuration. So the way they config is different. So you cannot use automatically machine to work with that. So Kun Somsak helped me a lot to do this kind of job, and also the student help together in terms of after we get the battery cell, we do some kind of discharge. So the way to discharge is just general way we put that in the sodium chloride solution for about 3 days, or optimally submerge into the sodium chloride solution about 3 days. Less than that, the charge may not completely discharge. And also after that, we have to dry. Yeah, after the process of 3 days or 5 days, we have to dry naturally. So we put that on the rooftop of our research building, Thammasat University here. Of course, the by the health by the health of, I mean, by the very hot temperature here, we can dry it within 5 days. I mean, the whole process to prepare the battery cell before the crushing process take about 2 weeks. And after that, we put the cell together and then go to the process unit. Of course, the process unit is about the crusher, so it's quite a lot of emission, dust coming out, and we have to work with very hard power, strong power and with big power, and electricity is quite very need to be input into the process. So we have to do some meeting before doing that, and then this is the way that we run the process. So we put the battery cell into the conveyor and go to the process like that. So this is our product. Some product, it was very hot after crushing, so we have to cool down, and some smell coming out because we cannot dry naturally. Completely remove those electrolyte. So we have to keep it somewhere outside the process plant. So let's see if somebody have never visit our factory. You can take a look on this process. I think I will just go love it short. So, okay. The process actually, this unit, the capacity of this unit is about 800 kilogram per day. However, we run only 400 kilogram per day because we don't have many people to help to collect the sample. And if we cannot take care of the sample fast enough, the sample maybe go out from the container. So that will be cause our trouble. And also, we design this unit have to be under the regulation. By the regulation, it said that you cannot have the process higher than 50 horsepower. So in this unit, we have to take something that unnecessary out, to have the total horsepower about 49 of horsepower. I would like to explain a little bit here before running the video. So this is a conveyor. After we place the EV cell onto this holder, the conveyor will bring this EV cell for the first crushing. Down here is a screener, and then the bigger one will go to another conveyor and go to using the density separation, air density separation, to separate the small size particle out, or maybe some separation sheet go out, and it will go to cyclone, and the bigger size of particle will go down for another separation here. That will be the same procedure to the second part, the second and the third of our cyclone. We also have these unit to separate in case separate iron in case that we have the LFO battery running operate into the system. On the top of cyclone is all the emission will take into the filter what should I say? Backhouse filters. So you can see the first backhouse filter here, the second and the third one on the rear side. Okay, let's continue for this video. This is what happened when the alignment of the construction is not very good. So we found some leak around here. So what they are doing is try to fix. Okay. So now this is this guy try to feed the battery cell into the system. Okay, this might be, oh, sorry. Okay. Okay, that's you can have some imagination for this kind of operation, right? So now we continue to our work. So as if you look at this 3D diagram, 3D model, see we have 3 cyclone here, 3 backhouse filter on the right side. We have crusher here, we have grind shredder here, and we get iron separation part. 1, 2, 3 screener. Each screener have 3 separation sites. And by this 3D model, we can correct about 14 points of correction sample. And this is our products based on different parts. This is from the second point right here, third one, fourth, fifth, blah, 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 until 14. It cannot see clearly, but if you look at this, some are very quite black, and some is contaminated by other kind of copper or aluminum sheet. Particular to this one, it can be used for other burning process. So from that, what we have done, we have to make sure that which correcting points that can be put together in terms of good product and bad products. So we check by the XRF and XRD, also ICP. This is just like the example. I mean the characteristic checking by the XRF. If you look at this table, we would get, of course, XRF cannot measure or uh, uh, do any measurement for carbon and lithium. So the portion of this may, after exclude of those. So you get nickel, you get cobalt, copper, and manganese, of course, right? So this is just want to confirm that, okay, of course, what we put in, what we should get out, right? So just want to check that which correction point that we should put them together. So this is XRF again, but however, from this table, this is confirmed that the raw material or sample that we sample out come from the LPF, not LMO or LCO. So we also we did several characterization by the XRD in each correcting point. So this is some example. So we get very good portion of, very clear of LMO to this one. We did the measurement of the for element particular to the lithium that we would like to know exactly where we should put them together, and we found that this is quite very good, giving about 24 gram per 1 kilogram of black mass. And other part may contaminated by other kinds of metals. So what we learned from that, we can, from that disassemble, from the crushing, we can do some kind of material flow analysis here, starting from battery income of 100 kilogram. So what we get from the black mass, we get about 70. It would be around 70% of black mass that we can get from 100 kilogram input. However, some bad black mass, bad quality, poor quality of black mass can be also also sold in the market. However, this is the mix of plastic or separation sheet in the black mass, about 12%. Now, what are the left? They go to other kinds of aluminum sheet, like a case, and plastic total, about 3 kilogram of plastic total, iron, lead, and also copper. So this can be sold directly to the what should we call small retail of people who grading or the waste. We also put the utility together. Utility, what I mean is about the chemical that we use, and also water and wastewater come from the during the process, and also electricity input into the process. So this is what we come up with. So some of them may lost, some of them may be only dust, some of them contain a lot of copper and aluminum. Some of them can be sold in very good price. Now let's check of the life cycle assessment between two scenarios. One is using crushing process on the left-hand side, and the other one is using incinerator on the right-hand side. And this protocol using the data from CIMA-Pro 9.4, and also some data in Thailand using, from the Thai Greenhouse Gas Organization. So we evaluate for 5 categories of environmental impact. The one that we have to take care the most is the global warming potential. Of course, if you look at this scenario B, take care the black mass from using incinerator, right? This is very big amount of emission came out to the environment because the temperature that they use is about 800 degrees Celsius, of course, and the process cannot run in very high capacity, only 4 tons a day, and of course they cannot run totally of 4 tons a day. They run only maybe 2 tons a day. So if you look at that, the emission is higher than what we use in the crushing process. However, if you compare in terms of human toxics, right, the number still lower, because this is not only even they have the cross system to take care of the air pollution. However, the chemicals that used to do the treatment on the air chemical part may consume very high, so it's still high in terms of human toxics. Okay, we also check with the air pollution inside. We install 2 sensor inside the process and one outside as a reference. Not very good in that day that we operate. As you can see from the gray bars here, all of the data almost meet to the standard emission, which is 50 microgram per cubic meter. So of course, during the operation, the emission may be very quite high. So this is what we learned, that we need to do, that we have to take care of the unweld connection or alignment to reduce the leak. And also this is, we cannot avoid on that because we do that correction or the collection point working with manually. This also appear the result show in very high PM 2.6 up to 2.5 also, which is very high, much higher than the standard of 25 microgram per cubic meter. In terms of total suspension particulate, we can do the control very well, as well as HF, which is one of the very toxic chemical in the electrolyte. We use GC mass, and the number is still lower than 3 ppm. Of course, the process of crushing and threading may cause a lot of noise, so we check by the average level noise, level noise, and maximum level noise by using the time weight average regulated from Department of Industrial Work or กรมโรงงานอุตสาหกรรม or by Ministry of Labor. So if you compare the data here, the red rectangular here still less than 85 decibel A, and the green rectangular box here are less than 115 decibel A. So the noise in working area is still under control. If we look at the health check before and after the check, we also the project under 2.6 ton total operation still under less than the health check of all 16% less than standard, which is make me happy. So now we come across to the economic point of view, right? If you look at the black mass under benchmark price spotlight, this in general there are about 4 market point market price. One from India, one from China, and the other two is, of course, American size and European market. However, if you check that the trend will be pretty much the same, so I give you the example of the price of black mass from China market. So this is the price by lithium carbonate. It's very high, about $10,000 a ton, right? If you look at the graphite, where is it? I should have the graphite here. It's about $800 a ton. So if we can give the we do the economics point of view because we would like to know this process is feasible or not. So we do the we check by the we used all the operating costs, of course, how many students that we take care, how many days, and how much that we pay for them, and how much that we have to buy the battery, and also the chemical use, water, salt, and the operating cost, and how much electricity had to be used in all activities. So put them together, and that would cost around 1,800 baht for total operation of 2.6 ton. However, when we use this data to analyze for the sale price, we separate the black mass into two qualities. One is the good quality, of course, a lot of lithium, cobalt, copper, and based on the reference we have, they have the specification of the black mass in general, how much it should be contained. I mean, lithium, cobalt, copper contained in that, also nickel as well. So we use the characterization that we made it from ICP to make sure that we separate good quality of black mass and bad quality of black mass. So it's come to be like a 75% and 25% here. So the total price is about attractive comparing to the operating cost. So what will be our further research? Yeah, we think about the collection node, right? Now we have to go to other shops and then buy it. We would like to have some kind of collection node, and also we cannot do the crushing and do the process in the mixed battery like that. We have to do some kind of separation, LFP, LMO, LCO. So the process in terms of chemical process here will be easily if we can do the sorting in this part first. And then we already have mechanical process, crushing and trader, right? So we get black mass. Now we are going to EV3, which is the chemical process. So this is our draw PFD in our proposal and go to under evaluation, but unfortunately we get some news on that we will continue this work. The proposal have been approved, so we're going to work on the lithium extraction and some other kinds of metal. So if you look at the closed loop recycle system, we need to work on sorting machine. Right? We already have that. We are going to have this. So only this part, which is quite difficult. So I think AI. I think the way to do the sorting will be make the process the first step the first part of the recycle system and the second part of recycle system work very well if we have this sorting machine or sorting system before coming into the process here. All right. Last but not least, this is I would like to thank all of these workers, of course, undergrad student and graduate student to help me and help the staff or the research group to success on this kind of work. Thank you very much. ขอบคุณครับอาจารย์ So now open for the some question.
Thank you so much ค่ะอาจารย์ So yes, so right now if there anyone would like to ask question, please feel free to type in the chat. So the chat box is on the upper right corner. You can type in the chat, or if there is anyone would like to go on stage to ask question personally, just type in the chat as well, and then I can invite you on stage. Probably I will ask Professor Nurak in the meantime. Like just wonder, like for the lithium-ion battery that you get, for the spent lithium-ion battery, like so what is the type of the battery that is the most common? Is it LMO or LFP?
Well,
and is it mainly from the electric bike or from like which source of the lithium-ion battery that we have a lot in Thailand right now?
As I found that in the market, the one that I have is LFP and LMO. Yeah, two of these.
So that's the main one that you found in the market at the moment.
What's that? You can find this kind of two cars battery in the motorbike market. Yes.
I see.
Some
so
of them.
In motorbike, not much NMC, right? Not much.
Yeah, there are, but not in. I went to two big companies. One is in Ayutthaya area. No, close to Antong province. They use half LFP, LMO, and a portion of nickel metal halide battery.
Yeah. I see.
But if you buy some cheap motorbike or cheap EV bicycle, e-bike, you can see some kind of zinc. Not very. Yeah, they don't use this kind of battery.
I see. Or maybe lead acid, something like that. Right?
Yeah.
Oh, there are so many questions in the chat right now. Okay. Okay, so for the first question, what is the limitation of applying this technology
the
in large
limitation
scale?
of this technology
In the
the
large
large
scale.
scale. Okay. I should say that the limitation in the large scale, the limitation is the way to prepare the battery before the crushing. We have to take care the battery before the crushing not to be too much moisture. Right? If you have too much moisture, it's very difficult to, I mean, it's very easy to stick into the unit inside. Okay. We cannot have a large scale. What does it mean by the large scale? I think maybe you are talking about the big battery, right? The big battery like that for the truck.
So could you please confirm?
I'm not sure. I'm not sure.
Not top on, right? Not top on. Could you please confirm what do you mean by large scale?
So this is large scale, right? They use that because they don't want to have smell. They don't want to have bad odor in the process. That's why And this is very dangerous on the way of disassemble. So they use that in incinerator instead of using the crushing process. Of course, in right now we use two techniques, crushing process and incinerator to take care for the recycle process. So you have to
uh,
uh, you have to classify your battery as in small scale, in small size. So I suggest that we should go to crushing process. But if you have like a big car, like this one or this one, I suggest that we go to incinerator instead.
I think there is more explanation on the large scale. So she mean it's the large scale operation. Like for
Yeah,
example, you can do 400
oh,
kilogram per day right now.
okay, I can do 800 kilogram per day. The limitation is we can the way we design may not very practical on the collecting point. So we have to uh, what should what should I say? It's difficult to correct if they go 800 kilogram per hour, 800 kilogram per day, right? It's very hard to correct the sample. So we cannot, we don't want to spill the product out from the container. This is only the way that we got the problem. And of course, when you run at 800 kilogram per hour, the emission, the dust will be like a small, small cloud inside the process because our process is inside the building. So that's why we have to reduce to 400 kilogram per hour. Kilo 400 kilogram per day, sorry.
Thank you
That,
ค่ะ.
that would be some limitation in terms of emission and the correcting system.
Okay, so next question, how much energy, maybe electricity, do we need to extract this lithium per kilogram?
Extract or only crushing. Right now I explain only in terms of crushing. So if I look at this, if I look at see, it's about two no totally 2.6 ton, right? 2.6 ton. We spend around 600 kilowatt hour. So not if I convert that into price is around the cost is around 2,000 something. Yeah, just like you are using electricity in your house for 1 month.
Okay,ค่ะ. Next question from Dr. Lukman in Indonesia. What efficiency for the process? What is the efficiency of the process? Is there any waste during black mass production?
Okay. Well, if you look at what's that? The mass balance, material flow analysis, material flow analysis here. Okay, we found that some loss, of course, the balance of mass, not completely 100%. However, uh, uh, efficiency, I should say, very close to 95% efficiency on the way of crushing. Of course, if you look at the process, it's nothing else that we can lose. However, the waste that we can gain from here is from the disassemble. So the answer is depend on what they fabricate, what they construct the battery coming in, right? See, if you have this car battery, Oh, very easy. You will get more than 97% black mass. But if you have this car battery, of course you will get some kind of waste like aluminum case, uh, iron case, iron handle here, or plastic right there. This is not general plastic. It's like a thermoset plastic. So mm, we can classify that as a industrial waste. So that's why what I do in the material flow analysis here. So I put that this is a part of assembly, right? This is a part of crushing process. So from here, 81% of sale coming here, and you would get about 1 or 2% loss. All the product will come here. And of course, we classify them into two kinds of product, right? Because we can use that, we can calculate that with the price that we can sell. So of course, we need to use characteristic to separate them. So I would say that in the crushing process, you would get about more than 95% of the product. Of course, 60% go to the good quality, 30-40% go to the bad quality. Yes.
Okay, thank you,ค่ะ. So next question is, will you try to do this with the EV car battery? Since the
No.
motorbike battery may be the minority of the market.
Well, okay. I would answer this way. For the big car like a Benz, BMW, uh, Toyota, or any plug-in battery, when you have the problem, you go to the shop, right? You go to the car center, and when they do the replacement of the EV, the battery, they give that to the company. So you don't have to. I personally will not take care of this kind of contract car, because the brand car, they already have the contract. So what they do, they have to take care very well in terms of management. But the problem in Thailand, you will get a lot of problem on the motorbike battery, the e-bicycle battery, or any drone, the battery from drone. You will get a lot of problem on that. I got the experience going to the computer center, the computer market. I mean, like Sia or Future Park or Pantip. Uh, I asked for getting from like a laptop battery. We don't have very systematic to correct this car battery. So sometimes they throw away in the same garbage, a general garbage can. But I think this is should be something that we can recycle, right? So that's why I would not say that I will work with the big car, the brand car, just only focus on the small side car or any small delivery car like that.
Okay, thank you,
And of
ค่ะ.
course, if you work with the uh, lithium-ion battery from the big car, you you need to construct some kind of uh, bunker on for the process of sharp release. It's not easy, and I don't want to uh, make some small bomb or any fire the inside my research building.
Okay, so I mean your technology can be used for the EV, but it's just not uh, I mean,
Oh,
but the moment
mm,
the problem of the spent EV battery is not as much as the motorbike, right? Because they already have their own management of the spent.
right. That should be the answer, I think. So we better to use the appropriate technology. Of course, incinerator used for the big EV, big uh, big EV battery, and the crushing may appropriate applicable for the small size battery. Yes.
Okay, so next question asks about the additional steps. So after this example, is any additional steps required before hydrometallurgy, such as heat treatment?
That's what I think. But at based on our experience right now, we didn't do any heat treatment. But I talked to professor from Japan. He suggests me to also put this kind of effect in our research as well. So now in our lab, we also doing the general way of hydrometallurgy, and also we just buy a new phosphorylation. Of course, the phosphorylation we need a surfactant, and before using the surfactant to separate the metal extraction, we rather use some kind of heat treatment before that. So thank you for the question.
Okay,
But that
so
would
follow
be
with that.
our further research. ครับผม
Follow with that question. What is the required structure or complex of lithium for creating the new lithium-ion batteries?
I couldn't answer that question. It's beyond my knowledge. Sorry about that.
Okay, so
I just know how to destroy those kind of
okay,
work.
okay,
Not about the fabrication. Sorry about it.
Also, the question about the water treatment. So, water treatment plant should be integrated in the recycle process as well. Or it's more
Yes,
like more okay.
yes. Okay, let us say this way. Uh, some water treatment. Okay. What should I say? This is what have seen in the industrial way. Of course, the wastewater not very much here, and you can do the recycle, right? So, however, wastewater treatment is required, but what they do in the industrial scale, they use evaporator instead of having like of having uh, general wastewater treatment. Yeah, you can imagine, right? If you have the wastewater treatment, of course, you need settling tank. You have flocculation. You have aerobic treatment. But in this part of recycling process, we don't use much of the water we use. So evaporation uh, wastewater treatment will be one appropriate technology to do the treatment of water. That what I think and suggest right now based on my visit to other companies, yeah, and talk with the engineer in that sense. Not much water, not much wastewater uh, produced in this process. Yes. Does many type of battery make it hard to do scale? I don't know, but I think sorting machine to separate different kinds of battery will be very it is necessary to make the second part of recycling battery easier. That's what I think. ทำไมคำถามเยอะจัง Any more question อาจารย์ปิดไมค์ครับ
Sorry ค่ะ so the question will be like, does many type of battery make it hard for the large scale, like hard to disassemble?
Anytime. No. I just as I answered before, I think the sorting of battery before coming into the process, entering the process, is quite necessary. So if you can separate LFP, you can read in any articles. Many articles suggest that LFP is not very good economically to do the recycle because the content of the precious metal only from three of them. I mean, majority from as lithium, iron, and phosphates, right? So as you knew that iron is very cheap, phosphate is not high in terms of price, only lithium. So you can sell lithium. There is not much portion, right, of lithium in LFP. So if I prefer to have raw material in our system, I prefer LMO because I can get nickel, I can extract nickel, I can extract. See here, this is LFP, right? Not much nickel show up here. But if you look at this, you can get also nickel as well. This is LMO. So sorting is the first step to do.
Oh, and Professor, when you mentioned about the water treatment earlier, that you use like maybe use evaporator, in that part you mean for the crunching, right? Crunching process. Not about the hydrometallurgy process. Right?
No. You can see from here, we have the filter plates, right, to separate those
from the hydrometallurgy process, right?
Right. So that's why water will filtrate out, and then it will not much of water or anything can be recycled and adjust for more sodium chloride, or I mean acid pH. We can adjust the pH later. Yes.
Because we use that water for the next process.
Right. We
treatment,
can recycle that part.
Okay,ค่ะ. If there is no more question, let's thank our speaker again,นะคะ. Thank you so much, Professor Nurak, for very insightful talk today, and we have learned a lot more about this crunching process, ค่ะ. Okay,
ขอบคุณมากครับ Thank you for many questions to in this talk, and I'm sorry for some questions that I cannot answer. I just focus on.
There is a question about the internship, Professor. So this question whether there is any internship for graduate student ค่ะ to work in your lab.
No. Is there any question here? Maybe we can talk about this later.
Please
I don't have
contact
money.
Professor Nurak directly in case that you're interested in
Well,
doing
you can contact me because we are going to have EV3, right? as you can see that we are going to have EV3 and the system of EV3 almost we already designed the system and now we we building for the construction of that. Yeah, you can contact me directly. All right. But
Okay.
as you know that working on waste treatment or waste extraction is will be very dirty and you have to be patient working on this kind of job. Right. And of course the way that I do I'm not doing on small scale. So dirty, smell, not very precious uh,
And
environment.
very hard
All
work.
right.
So today we have several attendants. Actually, I think the maximum we got is around 35 people listening to
Oh,
your
thank
talk
you.
today. Okay, so thank you all the audience
ขอบ
and
คุณค่ะ
especially
ขอ
thank
บ
you
คุณค
Professor
รับ
Nurak for today's talk.
ขอบ
Okay
คุณ
ค่ะ
ค่ะ thank you สวัสดีครับบ๊าย
Okay, so
บา
I
ย
will end the session for today. So thank you very much everyone. Okay ค่ะบ๊าย
thank
บา
you
ย
ครับ
ค่ะ
สวัสดีครับ